So I referenced a couple of times earlier talking about shape of a distribution and spread or range of a distribution. We're going to go over how we analyze and describe quantitative or numerical data. And again, this is for quantitative data. We do not do this for categorical data. And so there are different components of a data set that we talk about. And the one that we're probably used to most is talking about a central tendency, which is the mean or the median. Okay? And so in order to kind of remember the different components that we describe, we have an acronym. And that acronym is CUSS. C-U-S-S. And it helps us remember what those components are. We're primarily concerned with the consonants: center, spread, and shape. Unusual features we'll talk about sometimes, but when we're talking about a numerical data set, we always want to talk about central tendency, the spread, and the shape if we're asked to describe a distribution. You will not be prompted to say, oh, talk about the center, spread, and shape. You'll need to know those are the things you need to talk about when describing a numerical data set. So we'll start with central tendency. Again, you have experience with this. Mean or average is something that you've worked with before, and you all know how to calculate the average. And so if we had 18 grades, we would add up the 18 grades and divide them by 18, and that would give us our scores. There's something called a weighted mean, which for weights, maybe there's a certain percentage of one grade, maybe 20% of people got 60s, and 35% got 70s, and 25% got 80s, and I think that brings us to 80%, and say 10% got 90s, and 10% got hundreds. Well, in order to calculate the weighted mean, we wouldn't just average up the 60, 70, 80, 90, 100, because they didn't all appear in the same frequency, and so you'd multiply the x, the value, by their individual weights. Okay, and so here's an example for a weighted average. And so you have a midterm test was 83. Put that in. And your final exam score is a 95. Okay. Your midterm counts for 40% of your grade. And your final counts for 60%. And some of you might know this, but some of you might not have seen this before. And so this formula looks a little bit scary, but it's really not that bad. You could do it. So for this, in order to calculate my overall grade, I would do my score of 83 times that 40%, and I would add, it's the sum of these, my 95, which is my x, my score, times 60%, or 0.6. And so I'll do that quickly. And that turns out to be a 90.2. And so that would be your score, would be a 90.2. We would have a tendency just to take the average of the 83 and the 95 and say, okay, that's an 89. It would be an 89 if both tests were worth the same, but they're not. And so we multiply the score times their weight. And so the 4 40%, 0.4, already takes into account that there's 100% of your grade, and so that's the 4 over 10, or 40 over 100. And the 60% is 60 over 100 divided by. Since we already have it in percents, we don't need to use that other weight at the bottom. Okay, the median score is just the middle value in an ordered set of numbers. Okay. And then mode we rarely used, and use mode is the most commonly occurring value. Okay. So when we talk about things being sensitive to outliers, and outliers will just have a generic term for right now, and just say it's a number that's very large or very small compared to the rest of the data in the data set. The mean is more likely to change a lot if you add a gigantic number than the median. Okay, and so what's that said? And so if the mean is more impacted by an outlier, that means it's less resistant to an outlier than the median. And let me make up a simple example for this. And so let's say we have a data set, and I'll put them in ordered value. And let's say, I'll make it a kind of a simple set. Let's call it, there's a value of a 3, and a 5, and a 7, and a 9, and an 11. Okay. Okay, so there we go. All right, 5 values. And so for the initially, we have a mean and median of 7 for both. The mean and the median are 7 for both. Okay, middle number is the 7, and if you add these up divided by 5, you're gonna get 35 divided by 5, or 7. Okay. Now we're gonna add another value, and let's make it a let's be silly and make it a gigantic number. And so we're gonna make it I don't know, 85. $85 is our new number. Clearly an outlier. Okay. And so the new mean, when we add 85 to that gets us to 120 divided by 6. That works out nicely. And so that new mean is 20. And these, I'll put this in red because this represents the group, including the red number. But the median doesn't move that much at all. So we're going to count from the outside in. So the 3 and the 85 crossed out, the 5 and the 11. And so now we'll take the average of the 7 and 9. And so the median is 8. So the mean with this outlier increased by 13, but the median only increased by 1. And so we say the median is more resistant to outliers than the mean. That's it for now.